Good afternoon, drone enthusiasts. I am Anisha Patnaik and I am a Kumar, and it is my absolute pleasure to welcome you all to this outstanding seminar on drones. This event, Drone Dynamics, Light with Precision, Capture with Vision, has been made possible through the collaborative efforts of Aerolocus and the Robotic Society, and I am truly honored to be your host for the day. We would like to extend a warm welcome and express our deep appreciation to our esteemed chief guest, Mr. Jagati Mohanty sir from Aerologos, for gracing us with his presence today. Your presence adds great value to the season, sir. Please join us in extending our heartfelt gratitude and a warm welcome to Kumar Sahu sir, our esteemed executive advisor, Dr. Vijendra Rao sir, our Vice President of Technical Club, Dr. P.C. Jina HOD of Chemical Department, and Professor Sanjay Kumar Patil sir, our PSW Student Welfare, who have generously agreed to share their extensive knowledge and expertise with us. We are indeed privileged to have such personalities among us today. We sincerely thank them for the presence and contribution to this seminar. The robotics staff stands as an official technical club here at PSSUT Burma, dedicated to fostering technical activities and projects in the realm of amateur and advanced robotics within our university. This club serves as a hub for collaboration among robotics enthusiasts and professionals, igniting innovation and pushing the boundaries of robotic technology. Today, we have a captivating and informative program lined up for you, which promises to expand your understanding of drones. So, without further ado, let's embark on this exciting journey into the world of drones. Thank you all for being here, and let's make this seminar a resounding success. Now, I would like to invite Dr. P.C. Jena, sir, Authority of Chemical Department, to share his thoughts on this collaboration of a rover and robotics.
Esteemed August House, with your respected Vice President, Technical Society, Dr. B.D. Rao sir, Faculty Advisor, Dr. Santosh Kumar Sahu sir, and my beloved esteemed guest, today esteemed guest, Dodal Bhai, who is our alma mater, right? Am I right? And my dear students. And here I hope all are first year. How many second years are there? Okay. And third year students mostly aggregated are here to explore drone technology for societal benefits. In our very old days, if you think about it, drone technology was there with the Ramayana, with Mahabharata, right? With Lord Hanuman Bharat over their banner and over the ocean, he found one giant lady standing middle of the ocean, right? Who is one of the great soldier of Sri Lanka. That time of wisdom of that our Ravan, right? That time he tried to minimize his self to be on insect so that he can travel through his mouth and come back by his nose or nose, right? And that from that incident, what we learn, the miniature of the vehicle is very important. Though that time body itself is healthy on the Sri Hanumanji and it traveled nicely, managed how the body was to be minimized into an insect, right? Again, he wins his objective and reached the objective and Sri that the goddess Sita is there was there and he reached at there. Right? Similar way, another incident you will find Lord Varuna that time Lord Varuna one vehicle who will travel with him. He is velocity of mind, right? That latter part that is not Varuna. That is another no, no, another Varuna another Kuberas. Actually, Kubera is the elder brother of Ravana, right? From his, by forcing, Ravana achieved that Pushpa Viman, right? So it is also concept how growth was at that day. Now, in present scenario, we are looking our surrounding challenges from our day-to-day activities from health to agriculture. Everywhere we are looking the importance of small vehicle, right? Who will do the or who will solve the challenges of everyday life. When a farmer is doing cultivation job that is steady when grown up, that time many insects are coming, outside insects are coming. During time of now the time real time, they are coming from outside and destroying all crops. Right? It is right time this month only, October month and November month. I think I am close to farming family. I observe very closely. It is happening with the farmer. So they to avoid or to overcome from this challenge, we need a machine or a vehicle who will do this job rather than a farmer. A farmer can monitor from his house or from outlet of the farming land. He can monitor the that all the things how insects go away from his land, right? By providing different pesticides, right? Or by making different noise, if it one in certain frequency, the insect may be destroyed. It will develop some noise by using this winning acid, right? Vehicle that can be solved. And without using pesticide, it can be overcome. The matter. In that also the important rule. Without using pesticide, how can we destroy the insects? Right? And next is suppose in rurality people are not connected by road, right? How a how an engineer will reach to him, or how a doctor will reach to him, or how a lawyer will communicate, document how it will receive. All the things by those technology, right? So next is security system. We can implement it towards border line, right? Where it is difficult to solve by directly. We though our soldiers are very strong, still some condition was there is there how to manage the situation that drone can be implemented at it. So drone question will come to your mind, right? If you such very large things are doing by drone, all this meaningless thing, micromesh, right? Or vehicle. Now question is coming to our mind, what is drone is basically breed of mechanical, electrical, and computational, right? Three things are here, right? For mechanical part, when you will see, it will support to the structure. Mechanical, people will how the things will design that fan. You can see physically the how the fan blade is to be designed so that it will sustain. And another challenge is material design, right? It is a plus to carbon composite, right? And the carbon composite, now the variety of carbon composite is there. It may be particulate form, it may be fiber form. That can be incorporated in design when you are fabricating the blade. Then come to the structure. That different wings are there to hold the all arrangement of electronics part. That motherboard is there. That a microprocessor is there to hold all the things, and battery is there to provide the energy. Right. Next is programming panel is there. It can be Wi-Fi system. Right. Nowadays, earlier it was like where or sometimes now it is a Wi-Fi system. So you can communicate or transmit your data to the motherboard, right? And which is integrated at there. It will control. So when is the here mechanical structure embedded with the mechatronics, that electronic structure, then input command given by the communication system. That you can say your computational field will communicate. So being this house is not less than this three domain. I think it is more. Right, around 50 to 15 domain people are here to explore things, how it will be reached in certain level. Now you see that Dodati Babu, he already center of education at here 4 years, and after that he secretary to your next batch, gradually, and your upper batch also many batches also explored in this thing, and they reach in this level, right? It can be go in a other in a higher level. The size of the vehicle can be decreased, payload can be increased. That is the challenge for a designer, right? So now just during my discussion, Sarajit told that payload is 25 kg for this bigger drone, right? Energy capacity for 15 minutes, 30 minutes. It can store, it can run 30 minutes. After that, it will drive, right? So there is a challenge again that chemical people there is a challenge how the battery life can be increased. You take that challenge. So new solution comes. If it comes, you incorporate that. And next is what I understood that a motherboard part, that is integrated circuit part, it is very large size. What I observed, it can be minimized, right? So version is day to day version is changing, right? That electronics version is changing. We earlier we used to TV large size, that a box television LED, then is phototype, photography. So now that gradually it is changing. So there is also challenge of all electrical and electronics engineers. They go ahead how to minimize the circuit design and maximum data can be possible to handle. Right. Next is computer science. We communicate the things in between structure and electrical system. That computational field will come to your picture. So you make the program such that so it will be do always soft landing one, because here hazardous condition is when it come to landing point, that time it gets a jolt, right? So many cases that a structure is going to be damaged or utility can be damaged, right? Next is motor. Motor has a role at here. So actually I started my
His commitment to the growth and development of the drone industry. Let's give him a round of applause as he joins us.
Thank you for organizing. Good afternoon, all faculty members and all the students present here. Thank you to the BSS Society for inviting us, College Society for inviting us for the seminar. Before I start with the topic, I'll give you a brief introduction about myself and our company. My name is Rajani. I'm one of the co-founders of Aerorovers, and I am also an alumni of BSc Bulla. I graduated in 2017. After my graduation, I joined IT, Deloitte, and 3 years later, I quit Deloitte to pursue entrepreneurship full time. We started with Aero Rovers last year. All of the founding members of Aero Rovers are alumni of BSc Bulla, and we manufacture multi-copter platforms for various different applications, as you can see, industrial, agriculture, FPV, cinematics, and a lot of different applications as well. So our story began in 2014 in Burla. We were one of the first people to manufacture multicopters, and since then you can see where we have come across. And today, the topic of this seminar is mastering the studies, designing, and manufacturing of multicopters for various applications. So, I'm going to give you all a brief about introduction about how to approach drone manufacturing, how you select the components, and how you choose the components, why do we choose those components, how do you integrate it together, and basically get the drone up in air and fly. So these are the topics that we are going to cover today. The different types of multicopters that are available. How does a multicopter fly in the air? How does it move about? How do you plan and select the components? How do you select the flight controller, the processor, all the software? Then we'll take a look at the circuit of the drone. How do you make all the connections? Then a brief overview into the programming and tuning of the drone. And if time persists, we'll have a short demonstration afterwards. Starting with the type of multicopters. Multicopters, what does the term multicopter mean? Multi means more than one. Copter stands for propellers, the number of propellers basically. So depending, the multicopters can be categorized into a lot of different ways based on the size, based on the number of propellers it has, based on the weight, based on the payload carrying capacity, even the type of battery that it takes. Can categorize multicopters in a lot of different ways, and the designing part starts with main agenda. What is the purpose of your drone? Whether you are designing a drone for agricultural purpose, whether you are designing a drone for industrial purpose, or whether you are designing a fun little FPV drone like this one. So the first step in our process is figuring out the purpose behind our multicopter. Next slide, please. Traditionally we have, like I said, multi means starts from more than one. So the first design that we have is bicopter and tricopter. Like the name suggests, a bicopter means two propellers. Okay, and a tricopter has three propellers. Now these two designs, these have become outdated for a lot of different reasons. They are have more mechanical moving parts. That is the reason we do not see these designs in the present day market, commercial market. But this bicopter that you are seeing, this is an exception to that. This is the latest model by one of manufacturers in Thailand. This drone name is XCG V40. It's an agricultural drone designed for very heavy payload application, but it has just two propellers. Reason they have done it is for more efficiency, but again, this design comes with a lot of drawbacks in terms of moving mechanical parts. You see, both the motors are mounted on two servos. Servo motor, I do not know if you are guys are aware of servo motors, but servo motor is basically a motor which has certain circuit put into it where you can get precise angle control. So all the motors are mounted on servos. And because of that, there is a lot of strain on the servos, which means the point of another failure for the drone. That is why we have moved away from the bicopter and the tricopter design and quadcopter design with four fixed motors. Like you see, all the drones that we have here, these are quadcopters. The reason is that we have less moving parts. The motors fixed. The motors are just moving the propellers. That is the only moving part in this drone. Hence, it is more robust. It lacks certain features of higher end drones, which I will show you later on. But it eliminates the basic functionality of a bicopter and tricopter. With tricopter, the blast is also mounted on the servo. And like with all designs, moving parts means point of failures and a very possible point where your drone can fail. Now, the reason you might want to build a bicopter or tricopter is very simple. It is from a cost and efficiency point of view. So a bicopter uses only two motors and a tricopter uses three motors. When you reduce the number of motors and propellers, your cost of the drone goes down. And also your efficiency goes up because the more number of motors, the more is the loss, energy loss that happens across the drone. And you're minimizing that by reducing the number of propellers that are on the motors that are there. So the quadcopter, it is a midway between both the designs. If we go to the next slide. So above the quadcopter, we have hexacopter, octocopters, which are 6 and 8 motors. So the quadcopter is a compromise between a hexacopter, octocopter, and a tricopter. It stands somewhere in between. You get four motors in quadcopter, in hexacopter motors. In octocopter, we have two variants. One is your X8 configuration where you have 8 motors parallelly all across, and you have a X4 configuration where the motors are on top of each other. One is on top and another is on bottom. The main reason behind using these kind of designs where you go for 6 or 8 motors or more is first the payload carrying capacity. What does payload mean? The amount of weight that the drone can carry. As you can see, all of the designs are primarily agricultural drones. These are designed to carry heavy weights, 20 kgs, 25 kgs, 40 kgs. These kind of designs support that. Other reason behind using these kind of designs is redundancy. So, in case of a quadcopter, if one of the motor fails, then the drone doesn't have the ability to stabilize itself. It is going to crash. If one of the motor fails, it is going to crash on that. But in terms of hexacopter and octocopter, if you have designed the drone properly, if you have selected the components properly, then if one of the motors fail, still the drone has sufficient power and redundancy to land itself down. It will not come crashing down. That is where these kind of designs are more useful. But again, as you increase the number of motors, you are also increasing the cost of the drone. And again, the efficiency loss is there because the more number of motors, the more is the loss that happens in individual motors. So that is why I said the that is why I said a quadcopter is sort of a compromise between these two designs. A very optimal selection of motors, and the design has been perfected over years. And now the performance of the quadcopter is very robust because of the development that has happened throughout the years. That is why you see more moons nowadays. Those are based on the quadcopter design. Now, so we have something called as a VTOL, vertical takeoff and landing. Now the main disadvantage of a quadcopter or a multicopter is the flight time. Because we have 4 or more motors running, the energy consumption of a drone is very high. Compared to a RC plane, which you generally uses a single or two motors and has a wing, those kind of designs are very efficient. They can fly for hours, and in drones, we are talking about minutes. So, to get both the best of both worlds, this design has been developed. This is a VTOL design. This is kind of a combination of a quadcopter and a RC plane. Like you can see, there is a RC plane here, and we have 4 motors across the wings. So what does plane RCP? They have a longer flight time, but what is the disadvantage of planes? Anyone? What is the disadvantage of a plane compared to a drone? Yes. Yeah, you need a runway to take off and land, right? So to eliminate that problem, what this drone does is it takes off and lands vertically. From any urban situation, we can just take off and then it turns to a plane when it's in flight. So during takeoff and landing, it operates as a quadcopter, and during its flight, it operates as a plane. By doing this, the energy consumption during takeoff and landing is high, but the motor. Hello, because 4 motors are running during takeoff and landing. That's why the energy consumption during that part of the operation is high. But whenever it moves to forward flight, then your energy consumption is low because only one motor is running and the rest of it is supported with the design of the wing. So whenever you are looking for a drone that is optimized for longer flight duration, you are looking at a VTOL design. So all other applications, you either want to go for a quadcopter or XR or octocopter based on your requirement. Now, how does a drone fly? How does it generate lift and how does it move about? So in a drone, we have 4 axes of movement. What is the axis of movement? If I take a drone, how can the drone move? First is up and down. This is one axis. We call this axis as the throttle axis. Then you also have your roll. Roll is to the left or to the right. Then forward and backward is called pitch. Goes forward, it comes back. Then you also have another axis of rotation that is called the yaw. It rotates on its axis, curling of the roll. So these four controls or the four axes of roll, these are controlled via radio. What is the radio? Like you have a steering in a car, to control the drone, we use such kind of radio controllers where you have sticks on both sides to control the drone. Now these four axes of movements are controlled by the radio sticks. You have your roll on the right hand side, roll and pitch on the right hand side, and your throttle and yaw on the left hand side. These correspond to individual channels of control which I'll go into depth later on. Just keep in mind the drone has these four axes of movement and it is controlled by the radio. This is from the control point of view. Now let's understand how does a drone fly. How the motor generates thrust and how does it actually fly. So if we were to take a look at the propellers here, just think of a ceiling fan, for example. A ceiling fan is fixed on the top and it rotates and air is pushed downwards, right? Now, according to Newton's third law of motion, air is being pushed downwards, the air must exert some amount of force on the fan itself, right? Newton's third law of motion, every action has an equal and opposite reaction. So, because the ceiling fan is fixed at a point, we are not able to realize this force. We are not able to see this force. But a drone, whenever it is flying, it is suspended in air. So, the drone flies by pushing the air downwards. That is the basic principle of how a drone flies. It pushes the air downwards, and the amount of air it pushes downwards, it generates the thrust and it lifts up. Now, if you were to take a look at cross-sectional view of a propeller, it is at a slight angle, right? These propellers, these are at a slight angle. I'm not sure if you're able to see it from there, but all the propellers they have a certain angle to it. Now, what happens is whenever the propeller is rotating, for a short period of time, you can imagine that the propeller is moving forward. It is moving forward in a short span of time. Now, whenever air is propeller at an angle, it will also exert the force at an angle, and we can bisect that into two components. One would be a vertical component, and another would be a horizontal component. I guess all of you know that whenever force is applied at an angle, we can redirect it into two components, one vertical component and another horizontal component. So these two components, the vertical component is your lift that provides the lift, and your what happens to the horizontal component? So if we were to design a drone where where exactly the horizontal component goes, the, hello. So this is your propeller. Force is applied in this direction, and we can hook into one is component. Hello. So when we have uh, motors and 4 propellers. Each is producing into hello, hello. So we have 4 motors in a quadcopter, and we have, if each individual motor is producing this force, so we have 4 into the amount of vertical force. Now similarly this horizontal force is being also applied. What is the direction of this horizontal force? If you see, the propeller is moving in this direction, right? For a short amount of time, you can assume that the propeller is moving forward in this direction. The applied horizontal force is in the opposite direction of the movement of the propeller. So if a propeller is rotating clockwise, the net resultant force on the propeller is counter clockwise. The propeller is rotating counterclockwise, the net resultant force on the propeller is clockwise. So if we were supposed to have all the motors of a drone rotating in a same direction, then this horizontal component of the force would also be multiplied 4 times, and if all of our motors are rotating in a clockwise direction, what happens to the drone? It starts rotating in an anti-clockwise direction. It will lift up, but it will start rotating in an anti-clockwise direction because all of our horizontal component has been added together. To cancel this out and to get control over the rotation of the drone, what we do is we take we two motors clockwise and we take two motors counterclockwise. So this is same for a quadcopter, for an hexacopter, for an octocopter. When you have even number of motors, you just equalize them. You just balance it out. One is clockwise, so the other should be anti-clockwise. That way, what happens is that way you have two motors clockwise cancelling out two counterclockwise motors. The horizontal component of the force is cancelled out whenever the drone is steady. This is the force that acts on the propeller. Does this force convert into for throttle? We can easily understand that just by spinning the propellers faster, we can get the drone up and down, right? The more faster the propeller spins, the higher the drone goes. The more vertical component of force is generated, and the higher the drone goes. How do we move the drone left, right, forward, and back? Now, if the drone is flying like this, we have all the vertical components going down, right? But if I were to tilt this drone at an angle, now where is the force being applied? It is being applied at an angle, right? So the same thing would happen again. If the drone is flying, when the drone is hovering steadily, all the force is applied downwards, which in turn is exerting a force on the drone and it lifts up the drone. When the drone is at an angle, the air is being pushed in this direction. The force applied is on the opposite direction, this direction. Again, we will sort this out to a vertical component and a horizontal component. So now there's two the force acting on it. One, the vertical component maintains the height of the drone, When a horizontal component is moving the drone towards the direction the drone is tilted to. So for left and right, we can just simply tilt the drone and it will move in that direction. Is this clear? So that is the same for roll and pitch because the quad drone is a X shape, it's a quadcopter, same on all axes. So for forward, for backward, for left and right, we are just simply tilting the drone and the net resultant force is changing on the drone, causing it to move in that direction. Now the most critical part of this is the yaw. Yaw is the rotation of the drone. Like I said, when the drone is hovering straight in the air, we have two clockwise and counterclockwise forces cancelling out each other. That's why the drone is stable, it doesn't spin about its axis whenever it is taking off. What happens when, if we want to rotate the in a clockwise direction? We want to rotate the drone in a clockwise direction. How do we increase the force, clockwise force on the drone? We can simply increase the speed of the counterclockwise motors. Go to the next slide. So this slide would show you the change in the propeller speed that corresponds to drone movement. The forward direction is towards the top of the plane. This is the forward direction. This is the back direction. And for throttle control, you can see we just to go up, we increase the speed. To go down, we just reduce the speed. Same for pitch control for forward and back, we are increasing the speed of the for moving forward, we are increasing the speed of the back motors.